Hello, welcome to this little mini lesson on how to use the unit circle ordered pairs to evaluate trig functions of any angle. We'll talk about both the perspective of using your calculator to do some of these, but primarily we'll concentrate on the use of the unit circle to evaluate trig expressions involving angles in terms of pi. So let's start once again with the unit circle, or really any circle I suppose it could be. And let's just talk about first where the trig ratios come from. I'm sure you've heard of these before. If you think about a circle and we were to impose a right triangle into it, we'll have the central angle centered at the origin. Right, so of course the ordered pair here on the circle would be x comma y. We know the base is x. Height is y. Here's our angle theta that we'll be using as our reference. And we'll just refer to the hypotenuse as r, kind of the radius of the circle. So by the Pythagorean theorem then, of course, we know that x squared plus y squared will equal r squared. Since r is referring to a radius of the circle, we are assuming that r does have to be a positive value. So if we were to be solving for r, for instance, we're just going to use the positive square root. So from this and from this triangle is where the 6 ratios for the trig ratios functions come from. So remember, sine of an angle, I'm sure you've learned that in terms of right triangle trigonometry, is opposite over hypotenuse. So if we consider this angle theta, the opposite side is y, and the hypotenuse would be r. Cosine, I'm sure you learned, is adjacent over hypotenuse. And if we go back to our triangle, the adjacent side to theta is x, and of course the hypotenuse is r, so that would be x over r. Tangent then, you know, is opposite over adjacent. So going back once again to our triangle, opposite side would be y, adjacent side would be x. So there are our 3 main trig ratios. The reciprocal functions then, of course, come from these 3. Reciprocal of sine is cosecant. So that's going to be hypotenuse over opposite, so that would be r over y. Reciprocal of cosine is secant. That becomes r over x. And reciprocal of tangent is cotangent. Now, why these become important is that we're going to eventually relate these x, y, and r values to the unit circle ordered pairs that you learned about previously. So let's talk about the signs of the trig ratios and what is positive where. There's a lot of different acronyms to help you remember it. If you think in terms of x and y values, and we're going to think about those ratios that we just set up, over in the first quadrant, all right, of course our x values and y values are both positive. So if you think about all these ratios and how they involve x and y, and of course remembering r is always going to be positive, what ends up happening is in the first quadrant, all of our trig ratios are positive. So all are greater than 0. Moving to the second quadrant, of course our x's now are negative and our y's are positive. So if you think about the combinations of x, y, and r, so here in the second quadrant x would be negative, y would be positive, r is positive, so the only ones that end up being positive are anything that involve r's and y's. So in the second quadrant, the only ratios that are going to be positive are sine, and of course its reciprocal, cosecant. They're the ones that are going to be positive there. Moving to the third quadrant, now we have our x's still being negative, but our y's are now negative. R, remember, remains positive, so going back to our ratios and thinking about what combinations would produce a positive ratio in the end, knowing that x and y are both negative and r's are positive, it ends up that tangent and its reciprocal, cotangent, are both positive. And of course that ends up being positive because tangent, remember, is y over x, so you have a negative over negative, which becomes positive. Finally, in the fourth quadrant, x's now are positive again, but y's are negative. So if you think of our ratios and what combinations would produce a positive fraction, knowing that x's are positive, y's are negative, and r's are positive, it ends up that cosecant, or cosine rather, and its reciprocal secant end up being positive. This becomes important because later on, when we go to actually evaluate trigonometric expressions, we need to know the quadrant in which the angle lies in, because that will then tell us whether our final answer for the requested trig ratio is either going to be positive or negative. So as I mentioned earlier, there's a lot of little acronyms that will help you remember these. One of them that I know I learned early on, and perhaps you've learned, if you think of the first letter of everything that's positive, right, and we really only stick to the three main trig functions, knowing that their reciprocals are going to follow suit. Moving, around the quadrants from first quadrant to fourth, if you think of the A, the S, the T, and the C, telling us which are positive where. One that a lot of students know of are all students talk and chat. Another one, all students take calculus. So there's a lot of acronyms out there that will help you remember what's positive where. Eventually, I think you'll get to the point where you just think in terms of the x and the y values and whether they're positive or negative, and which combinations are going to yield positive ratios in the end. So another important idea that feeds into being able to evaluate trig expressions, and when we say evaluate them, we're pretty much talking about in your head without the use of a calculator, is something called reference angles. And when it comes to finding the trig values of angles that lie in the second, third, or fourth quadrants, we're going to do that by the use of reference angles. So by definition, an angle theta is if that's an angle in standard position. Remember, standard position means that its vertex is at the origin on the x and y plane. The reference angle is the acute angle formed by the terminal ray and the closest side of the x-axis. One way I like to think of it is the reference angle, it's the distance between the terminal side of an angle and the closest x-axis. That's an easy way to think of it. So if you think about angles in different positions, the terminal ray of angles in different positions in the coordinate plane, suppose you have an angle whose terminal side lies in the second quadrant. Well, then your reference angle is going to be the distance between where that angle ends and the closest x-axis. So that in this case would be the negative side of the x-axis. So to get your reference angle, you're just going to have to take pi, which would be right on the negative x-axis, minus whatever the angle is. Now we're assuming, of course, that we're working in terms of radians, in terms of pi. If you were in degrees, it would just be 180 degrees minus theta. Remember, in calculus, though, we typically will operate in terms of radians and angles in terms of pi. Now, if you envision an angle whose terminal side is in the third quadrant, again, think of the reference angle as the distance between where that angle ends and the closest side of the x-axis. So in order to find the reference angle in that case, you're going to have to take whatever angle it is you have and take away pi. All right, again, if you were in terms of 180 in degree measure, it would be your angle minus 180. If your angle lies in the fourth quadrant now, the closest side of the x-axis is now the positive x-axis. So when getting the distance there, positive side of the x-axis brings you back around full circle to 2 pi, and from that you take your angle. If you were in terms of degrees, it would simply be 360 minus theta. So we're going to be making use of reference angles as we determine and be able to figure out in our head how to evaluate a trig expression. So as I like to say, it's 3 easy steps. We're going to find the quadrant first in which the angle lies. We're going to find the reference angle and the unit circle ordered pair that's associated with that angle. And finally, we're going to think of the trig ratio of that reference angle, and we're going to affix the proper sign, either positive or negative, depending upon the quadrant that we found the angle to lie in. So let's work through a few practice examples. Suppose we wanted the cosine of 3 pi over 4. So that is in the second quadrant. Right? If you can always think of drawing yourself a picture if you'd like. So 3 pi over 4, here would be where the angle starts. 3 pi over 4 is going to be like right here. So in terms of our reference angle, this angle here is your reference angle. Right, now remember, this is pi over here, so our reference angle that we get is simply pi over 4. When you're dealing in angles in terms of pi, reference angles are really easy because it's always just going to be pi over the denominator. So we like those. So that's the first thing you'd want to figure out. The reference angle, obviously it's in quadrant 2. All right, and since we're finding cosine, we know from what we figured out before in terms of what is positive where, over in the second quadrant, cosine's negative. All right, now you want to think next of the ordered pair associated with pi over 4 from the unit circle. So remember, that ordered pair is 1 over square root of 2, 1 over square root of 2. Considering that it is a unit circle, remember our x values always are cosine, our y values the sine. So the answer for this one, in terms of what the cosine of 3 pi over 4 is going to be, since it's over in the second quadrant, we know cosine is negative, and we just need to grab the x value from our ordered pair. So our answer is a negative 1 over root 2. Of course, you could do it negative square root of 2 over 2 if you prefer. So it's really like you're piecing together little bits of information to eventually get you to the answer. The reason we can use the ordered pair from the unit circle, all right, remember how we talked about how everything on the unit circle is symmetrical. All right, pi over 4 is going to be this angle right here. So the ordered pair on that, for that, is going to be symmetrical to the ordered pair for 3 pi over 4, just that the x is negative. So we have a few more that will work out for you. Let's try the secant of 7 pi over 6. All right, so if we think about where that angle is located, it is going to be in the third quadrant. Think of 7 pi over 6 as kind of like 1 1/6 pi. So we know we have to go around the pi, but then a sixth more. So we're just a little bit into the third quadrant. So it's kind of like right here. All right, your reference angle, remember, is going to be this angle in here. It's the distance between where the angle ends and the closest x-axis. So your reference angle in this case is just pi over 6. All right, so if we think about the ordered pair associated with pi over 6 from our unit circle, it's going to be square root of 3 over 2, comma, a half. All right, so everything we need for our answer is going to come from that ordered pair. All right, remember pi over 6 is the reference angle, would be like this right here. All right, so that point there has the ordered pair square root of 3 over 2, comma, a half. You're talking about the point that's symmetrical to it down in the third quadrant. So it's going to be the same ordered pair values, just that the x and the y are negative. Now we wanted secant. Now remember, secant is the reciprocal of cosine. All right, we know since we're in the third quadrant, our answer is going to be negative. And since secant is the reciprocal of cosine, we want to take that x value and just do the reciprocal of it. So this is your answer. And you can leave it like that. It's perfectly fine to leave the square root in the denominator. So as I mentioned on the first problem, you really are just piecing together little bits of information to lead you to the answer. All right, let's do a negative angle. So if we think about where that's located, negative 5 pi over 3, if you want, think of it in terms of like a mixed number. It's going to be negative 1 2/3 pi. All right, so remember it's a negative angle, so you're measuring backwards. So you're going to go around to pi and then 2/3 of the way more around the semicircle. So that's going to put you up here, about. All right, so your angle went this way. Okay, your reference angle, remember, is going to be this one in here. It's the distance between where the angle ends and the closest x-axis. So the reference angle for this one is going to be pi over 3. All right, so you think of the ordered pair for pi over 3. It's a half, comma, square root of 3 over 2. So since we are in the first quadrant, we know our tangent value is positive. So when we want the tangent of a negative 5 pi over 3, right, remember tangent is y over x. So if we do our y value from our ordered pair over our x value, think of it, dividing fractions, you're multiplying by the reciprocal. So these 2's cancel out. So all you have in the end is square root of 3 as your answer. You might find it helpful to just go ahead and memorize your tangent values. I can list them for you quickly. If you think of just the reference angles that would be in the first quadrant, right, tangent of pi over 3, that's the one we really just found. That's square root of 3. Tangent of pi over 4, well, remember you're getting your tangent values by doing your y over your x. So for pi over 4, of course, those x and y values are the same. So that's just 1. Tangent of pi over 6 is 1 over square root of 3. Again, that comes from taking the y value over the x. So for pi over 6, you're going to have 1/2 over square root of 3 over 2, and that's where that comes from. So you might find it helpful just to go ahead and commit these to memory. They do show up a lot, so There's little tricks. The way I remember that tangent of pi over 3 is square root of 3 because it's 3 in the denominator. So it's square root of 3. Tangent of pi over 4, that's easy. And then tangent of pi over 6, I figure, well, that's smaller. It's 1 over square root of 3. There's lots of different ways to remember them, but you might find it easiest just to go ahead and commit them to memory. All right, let's try the tangent of negative 3 pi over 4. So I wanted to throw one of these in on purpose. All right, if you think of where negative 3 pi over 4 over 2 lies, rather, that is a quadrantal angle. It's up there. Okay. So when it comes to the quadrantal angles, we really don't think of those as having reference angles because it lies right on the axis. So if you just think simply of the ordered pair that would be up there on the unit circle, we know it's 0, 1. So even though it doesn't have a reference angle, we can still use that ordered pair to get our answer. All right, so it lies on the positive y-axis. Remember, in order to get tangent, we're doing y over x. So we have y over x. But we know, of course, that a 0 in the denominator makes the fraction undefined. So you can say that it does not exist. You can say undefined. A few different ways to express it. DNE, does not exist, is one that we use in calculus a lot. So it is possible that you could get an answer such as these. So we have one more. Let's do secant of 5 pi over 3. So if we want to figure out where it is, again, thinking of mixed numbers I think is really, really helpful. So this would be 1 2/3 pi. All right, so we know we have to go around to pi, and then 2/3 of the way more around the circle. That lands you in the fourth quadrant. So here's where the angle starts. So this would be your angle here. All right, your reference angle then is this angle in here. It's always the difference between where the angle ends and the closest x-axis. So in this case, your reference angle is pi over 3. So if we think of the ordered pair associated with pi over 3, it's 1/2 square root of 3 over 2. So in order to piece together what the secant is going to be, all right, remember we're in the fourth quadrant. This is the reciprocal of cosine. And down in the fourth quadrant, cosine, since cosine feeds off of your x values, and down in the fourth quadrant, your cosines are positive. It is going to be a positive answer. Secant is the reciprocal of cosine, so we want to grab that x value from our reference angle and do the reciprocal. So our answer is just a plain positive 2. So this evaluation of trig expressions is something you will do all year long in AP Calculus. So the more familiar you are with it and the easier you are able to do these in your head, you'll find that it is a lot easier for you because it will show up an awful lot. In one of the next lessons in which we talk about solving trig equations, we'll be doing a combination of this kind of work using the unit circle values, but also using our calculator to do some other kinds. So this lesson really just focused on the use of the ordered pairs from the unit circle in order to evaluate trig expressions.